Have you ever wondered how giant companies, the ones with trillions of pieces of information, manage to keep it all straight? Well, the secret isn't some kind of magic. It's the database. Today we're going to unlock the principles that turn total digital chaos into perfect, crystal clear order.
To really get this, let's just picture something. Imagine a million colored balls, all jumbled together in one giant pile. Now your job is to find one specific ball. It would be a nightmare, right? So inefficient, and you could never be sure you found what you were looking for. Well, that feeling of chaos, that uncertainty, that is the exact problem a database is built to solve.
Okay, so how do we tame all this chaos? Well, the solution is a database. But to really get how it works, we need to break it down into its most basic parts, and it all starts with the data itself.
So, the most fundamental piece of the puzzle is data. In our analogy, every single one of those colored balls, that's a piece of data. It could be anything, really. A customer's name, the price of a product, a single sales record. Each one is a single, important nugget of information.
Of course, having millions of individual data points isn't very helpful on its own. We need a way to group them together logically. And in our little analogy, that's where a table comes in. Just think of it like a clearly labeled box. You put all the red balls in one box, all the blue ones another. In a real database, a table just groups related data together, like a list of all your customers or all your products. Simple as that.
And this, right here, is the core difference. On the left, you've got chaos. Finding anything is slow, it's unreliable, but on the right, you have order. Finding what you need is fast, and you can trust that the information is complete. That is the fundamental power of what a database does.
So, we've got our data sorted into tables. We're done, right? Well, not quite. To build a system that's actually powerful and reliable, especially when you're dealing with tons of information, you have to follow a few core principles. Let's take a look at the 3 most critical points for any solid database design.
These are pretty much the 3 pillars of a great database. You want to avoid redundancy, which saves space and stops errors before they happen. You have to ensure consistency so you can actually trust your information, and you need to enable integration so everyone can get to the data they need. Let's break down what each of these really means.
First up, redundancy. This is a big one. Imagine a company where the sales team has their customer list, the marketing team has their customer list, and management has yet another copy. That's redundancy. It's just inefficient. The smart way to do it is to store that information, that one colored ball, in one central place and just let everyone access it from there. It saves a ton of space and prevents so many headaches down the line.
And that idea of a single source of truth is absolutely crucial for our second point, consistency. Data has to be up to date to be useful, right? If you make a business decision based on an old address or an outdated price, well, that decision is probably going to be wrong. A good database makes sure that when information changes, it gets updated everywhere, instantly, so everyone is working with the same, reliable, consistent facts.
And finally, integration. What good is perfectly organized data if the people who actually need it can't get to it? Think about it. If the production department's system can't talk to the maintenance department's system, they're basically working in the dark, in silos. Integration is all about building bridges between those silos so that different parts of an organization can communicate and share from that same central source of truth.
Okay, so we know the principles, we know the rules, but how do you actually go from a messy, real-world problem to a clean, efficient database? Well, it's a very structured design process. It basically moves from a high-level idea to a physical system, and it happens in 3 distinct stages or models. We start with the conceptual model. That's the big idea. Then we create the logical model to map out all the connections. And finally, we build the organizational or physical model, which is the actual system itself. Let's see how each of these stages works. The conceptual model is literally the starting point. You can think of it as a sketch on a blank piece of paper, or maybe a whiteboard drawing. You map out how a product moves from one department to the next, just figuring out the entire flow. It's the high-level vision, long before any code gets written.
Next up, we turn that rough sketch into a formal blueprint. This is the logical model. This is where we get specific and define the exact relationships between our data tables. We formally say, okay, the production table is connected to the maintenance table, and this is exactly how they're related. This is where the real structure starts to take shape.
And finally, we get to the organizational model. This is the physical reality. This is where the rubber meets the road. It defines how the data is actually going to be stored on a server, what programming language we're going to use to get to it, and how it'll be manipulated.
This is the stage where the blueprint becomes a real functioning house for all our data.
Now, building all these models and managing all this physical data, it can get incredibly complex really fast. But luckily, we don't have to do all of that heavy lifting from scratch. We have this powerful software that acts kind of like a friendly librarian for our data.
This software is called a Database Management System, or just DBMS for short, and its entire job is to make our lives easier. It gives us tools to recover data if something goes wrong, to change it easily, and to maintain these huge repositories. But most importantly, it gives users a simple way to work with all that complex data without needing to be some kind of expert. So here's the crucial point, the thing to really remember. Organizing your data isn't just about being neat and tidy. It's about creating a system that lets you operate with speed, lets you have confidence in your information, and at the end of the day, helps you make much more intelligent decisions.
So I'll leave you with this question. Just take a second to think about your own digital life. Your photos, your documents, your important files, are they all in neat labeled boxes, or are they all stuck together in one big chaotic file? The principles we've talked about today, they really do apply everywhere. Thanks for joining this explainer.